Hello everyone, myself Lohit Dalal, lecturer, Electronics and Communication Engineering Department, Jain Polytechnic, Belgavi. Today I am going to discuss unit number 3, registers and counters. Okay, in this lecture I am going to discuss what are the registers, classification of registers, realization of simple 4-bit serial input, serial output. Okay, and also flip-flop as a bistable, multi-vibrator, and also we are going to discuss first. See here, what is registers? Registers are the group of flip-flops which are the flip-flops which are capable of storing 1-bit information. Okay, so you take it an n-bit register is a group of n number of flip-flops. Flip-flop is a storage element or a storage device. Okay, the basic function of a register is to hold the some kind of information and make it available to the logic element. Okay, logic elements of the computing process. Okay, that is the working. Okay, that is the main function of the register. And or you can define under form a group of cascaded, means combined flip-flops used to store the bits of information in a known register, that is known as a group of information. Okay, that is stored. Okay, means number of flip-flops are cascaded or are combined and used to store the information is known as a registers. Okay, so next, classification of the registers. Okay, the register can be classified depending on its inputs and outputs and applications. Okay, depending on the input and outputs. Okay, so first one is the serial input, serial output. Okay, and second one serial input and serial input and serial output, that is a SISO, and serial input parallel output, that is a SIPO. Okay, and also serial input parallel output, that is SIPO, parallel input serial output, that is a PIS. Okay, and parallel input parallel output, that is a PIPO. Okay, depending on the applications. Okay, applications of the shift registers. Okay, so there will be a serial input serial output and parallel input parallel output storage registers. Okay, there are two types there. Okay, depending on the applications we have divided. Okay, classified, means shift register, SISO and PIPO. Okay, SISO is a shift register and storage register is a parallel input parallel output. Okay, see here, first one, realization of the simple 4-bit serial input serial output. Okay, so you can take an example. See here, consider that all the stages are resetted. Okay, you are going to reset the reset and logical input 1011. Okay, is applied at the serial input line connected to the stage. Okay, you can see here, and also you can see the table and also see the diagram. You can observe here. Okay, so you are going to shift serial input serial output, data can be shifted to right side. Okay, that is the 4 bits of data you are going to transmit, means basic 4-bit shift register can be constructed using the 4 D flip-flops. Okay, D flip-flops I am considering. Okay, here clear, clock, data input, and QAs will be there. Clock is common clock I am going to provide. Okay, so data output you are going to take. Okay, the register is first cleared, now cleared, forcing all the outputs to 0. The next, what you are going to do, the input data is then applied to sequentially to the D input. Okay, D side you are going to provide the input data first in first serve. Okay, on the and so during the each clock pulse 1 bit is transmitted from the left to right, means it is going to shift. Okay, assume the data is 1011. Okay, means what happens, the least significant bit of the data has to be shifted through the register from QA to QD. It is going to shift from to the last D flip-flop. Okay, QA to QD. So you can see the you can see the truth table. here how data can be shifted. Initial value will be what you are going to provide 0. Okay, so after that first clock pulse you are going to provide 1. Okay, next 1 1 1 0 1 1 0 1 you are providing, means that previous QA value should be shifted in a QB. Okay, next again what you are going to provide in a QA, there is a 1 that is shifted to QB. Okay, similarly that is going to shift QA QB QC, like that it is going to shift at the right side. Okay, from left to okay, that is the working of the 4-bit CISO. Okay, serial input serial output. You can observe the waveform. Okay, after the 4th clock pulse will get the first input. After the next 3 clock pulses complete input 1 0 1 1. Okay, so we are going to feed a flip flop A will out from the flip flop D. Now you can see the waveform here. Okay, we are going to provide the data, how data is going to shifted here. Okay, so here initially you are providing 0 0 is going to shift right side. Okay, so QA QB QC you can observe here. So next concept, flip flop as a bistable. Okay, bistable multi vibrator. Okay, flip flop as a bistable multi vibrator we have already discussed in the unit number 2. Okay, you can go through that video. Okay, so next you can observe. Okay, in this session we have discussed what are registers, what are the classification. Okay, different types of different types of registers, and realization of the 4-bit CISO. Okay, thank you.